Okay, this is the review for Unit 7 test. Alright, so on our first one, our very first one here gives us an equation that asks for our vertex, axis, symmetry, and roots. So we have to put this guy into y equals in our calculator. We don't know what kind of garbage our calculator is going to have in it from the class before us. That's no problem. We can start off by hitting zoom and then hitting zoom standard number 6. And it'll give us our standard window. Don't care about what's in there right now, because I'm putting my new equation in anyhow. So I hit y equals, clear. Put that equation in. Negative 4x squared minus 6x plus 6. I hit graph. Okay, when I hit graph, I have all the ingredients I need. This one has a good graph. It all shows me everything. It shows me my vertex, shows me my roots, and I have my symmetry. So that vertex, is that a maximum or minimum?
Maximum.
It's a maximum because it's the highest point of the graph. So I go second, trace, maximum number 4. It says left bound. So I put my little spider guide to the left of the vertex. Hit enter. Right bound. Put it to the right of my vertex. Hit enter. Guess. Hit enter. And it tells me my vertex is negative 0.75 and 8.25. So negative 0.75. 8.25. I think we're all good with being able to find vertexes. Okay? Axis of symmetry. Can we remember? That's an easy one. What is my axis of symmetry? It's always the what value at the vertex? X value. Good. And my x equals what at the vertex? What's the x? Which one is x?
7, 8.
Yeah. It wasn't 7.5. Did I mess up?
It's 7.5.
It's 7.5. My bad. 7.5. So it's negative 0.7. Motherless goats. 7.5. There we go. Alright. Roots. What are roots also called?
Zeros.
Zeros. So they are zeros in my calculator. The x-intercepts. Right there and right there. There's 2 of them on this one. Okay, so I go second trace. 0. Number 2. And I'm going to find the leftmost one, so I use my little cheat sheet that's on the board, and it tells me if I'm getting this one, my left bound has to be below the x-axis. So left bound, below the x-axis, hit enter. Right bound is above the x-axis, hit enter. Guess, hit enter. And we round to 1 decimal place is fine, so that'd be negative 2.2. So we have negative 2.2, comma 0. Now our next one, this guy over here, our rightmost one, second trace, 0, number 2. Tells me take my little spider guide. It should be, for a left bound, above the x-axis. For a right bound, below the x-axis. Hit enter. Guess, hit enter. And it tells me 0.68, which rounds to 0.7. So we have 0.70. And I can now sketch this. There's my 2 roots. So over negative 1, 2, and some change right there. And then almost to 1. And then my vertex was over almost to negative 1 and up 8 1/4. And it goes. There you go. So if you know how to do that, you just got a big portion of your test correct. Okay? Next up, we're using our calculator to solve quadratics. So I want to know what the x values are. Now here's the deal. There's always 2 of those x values. If there's a time that we might need to use the quadratic formula. So here it is again. You have it in your notes, but minus b plus or minus square root of b squared minus 4 times a times c all over 2a. Notice I put every variable in parentheses because it multiplies them for me if I do that. And it keeps my signs correct. So when would I need to use that? There's only one time I would even use this formula.
If it doesn't.
When there is no roots, when it doesn't cross the x-axis. So we're going to put the first one in and cross our fingers and hope it crosses the x-axis, and then I don't even have to use it. 7x squared minus 2x minus 12. Graphic, fingers crossed. Boom! We don't need it. So we find these two zeros, those two x values. X's are my answers. Second trace. Number 2 for 0. Left bound on this guy over here. I lose my little cheater sheet over there. It says put it above the x-axis, hit enter. Then it says right bound, so I put it below the x-axis, hit enter. Yes, hit enter. And it tells me negative 1.2. So one answer, negative 1.2. And my other x value here, second trace, number 2 for zeros. Go over here for a left bound. Tells me put it underneath, enter. Right bound, I put it above the x-axis, enter. Yes, enter. And it's 1.5. 1.5. I do a quick little rough sketch. So 1, 2, so right about there. And then 1, 2, right in the middle. And it goes. Bingo. Too easy. Next one. We plug it into y equals in our calculator. And hope and pray and cross our fingers. So we have 3x squared minus 2x plus 2. Graph it. Please, please. Snakes in the grass. It does not have zeros, so that means it's going to be what kind of numbers? Starts with an I. Some of you have this as a friend.
Idiot.
Ooh, good one. Y'all do have some dumb friends. But if they aren't really there,
Invisible.
invisible, but there's another word for it.
Imaginary.
Imaginary number. Okay, so here we go. Are these in ABC order?
Yes.
Yes, so I go A, B, C. What is my A value?
3.
My B value?
2. -2.
-2. My C value? +2. Alright, so I use my formula. Formula says minus, parentheses, B, which is -2, plus or minus square root of B squared. So that's -2, close it, squared, minus 4, parentheses, A is 3, and C is 2. All over 2 times A, which is 3. Okay, now I clean it up. A negative make a positive, so 2 plus or minus. We don't know what's under there. If you put that in, it's going to give you an error because it's a negative number. We know it's imaginary, so I know I can't do that.
-20.
All over 2 times 3 is 6. So in my calculator screen, I only put what's underneath without the square root. So it looks like this. Okay, I put it in just like it looks right here without the square root. Once I hit enter, it tells me -20. And we know you can't do that. Can't have a -20 under there, that's why we know it's imaginary. So I take this guy here, the square root of -20, and I move it to the side. And how do I get rid of that negative? What do I bring it out as? That negative comes out as a what? What letter? I. And I scratch it off. Break this guy down to Funky Town. What's he break down to?
5 and 4.
5 and 4. 4 will break down to
2 and 2.
2 and 2. So I got a pair of Nike 2s. They come out of the box. And I had a 5 left over. It goes back in the box. So this 2i square root of 5 took the place of square root of -20. So I'm going to put it in its place up here. 2 plus or minus, replacing square root of -20 with 2i square root of 5 over 6. Can I reduce that?
Yes.
Yes. What will go into all three of these?
2.
2. So final answer. Oh, and by the way, my rough sketch was that right there. So I divide 2 into 2. How many times?
1 plus or
1
minus.
plus I plus or minus.
I
Square root
5.
5 over 3. We agree? 2 goes in here 1 time, 2 goes in here 1 time, 2 goes in there 3 times. That's my final answer. That's it. for that. Okay? Too easy. So far, so easy. Okay? On these guys, we're talking solving inequalities. All I need to, the biggest part I need to know is what that sign says. It says it wants my graph to be what than 0? Greater than. So all I care about is stuff that is above the x-axis. I don't care about anything down here below it. Okay? If you graph anything below it, it's wrong. Okay? Just above it. So I go and I crank up handy dandy. Y equals clear x squared minus 2x minus 8 graph. I only care about what is above it. So these two antennas right there. This I don't want. Okay? Is it going to be open or closed circles? Open because it's not equal to. So I need these two zeros right there. So second trace, number 2 for 0. On this side, I put my left bound above, enter. Right bound below, enter. Guess, enter. One answer is -2. 1, 2. And I said I'm using above, so I'm going to put my answer or my number below it. You said open, yes?
Yes.
And the antenna went like that. Kind of a curved line because we know it's a parabola. Okay? Now our next one, second trace, number 2. Go over here, left bound is below the x-axis. Enter. Right bound is above. Enter. Enter. And it says 4. 1, 2, 3, 4. Open and I don't want the stuff below with the vertex. I just want those antennas. So now I'm taking these guys and putting them on the number line. -2 and 4. Open circles. Which way do I shade for my -2? To the right or left?
It's gonna be like this.
To this way, right?
Yeah.
It's going to split apart. The 4 to the right. Okay, because any number I choose out here on the number line would hit the graph. Any number I choose in here would not hit the graph anywhere. Okay, same deal over here. Anything outside, there. So I see I have two separate ones, so I have to have two separate x equals or x inequalities. So x needs to be what then -2? What are these numbers going this way?
Less than.
Less than. Or x must be what then 4? These numbers are greater than. Too easy. The next one asks me, when is my graph less than 0? So all I care about now is what's below. I don't care about what's above. Okay? So here we go. Y equals, putting in our new equation, clear, 2x squared minus 9x minus 5. Graph it. We only care about what is below. Okay? I really don't need my vertex. It's going to be a rough sketch. I just need those 2 points right there. Okay? My 2 zeros. So here we go. Second trace. Number 2 for 0. Finding this one on this side. So left bound is above. Enter. Right bound below. Enter. Enter. And it tells me -0.5. So there was -1. -0.5 is halfway. So put my little open circle because it's not equal to -0.5. Okay. Next one. Second trace. Number 2. Go over here for a left bound. Left bound is below on this side. Enter. Right bound is above. Enter. Enter. And it tells me 5. 1, 2, 3, 4, 5. Open circle. And it goes. Oh. Okay. So I go from -0.5 up to 5. Both are open. Shading which way? It kind of gives it away by looking at the graph.
Middle.
Should I shade in the middle or outside?
Middle.
Middle. Shading in the middle. Since I shaded in the middle, there's only one, so I put my x in the middle. -0.5 and 5. X has to be what then -0.5? What are these numbers? Going this way.
Greater than.
Greater than. But x must be what then 5? Less than. Too easy. And then our last one is what we've been doing the last couple of days, which is a word problem. And this one is another one where a football is being thrown. And it gives us the equation Okay, but first thing I want to do is label my axes. So my x-axis says x is the time in seconds, so I put time in seconds. And my y is my height in feet, so height in feet. Okay, next up I got to know what numbers to number these guys by, so I've got to actually put this in my calculator. Y equals, clear, negative 5.88x squared plus 28.1x plus 6.5. Graph. Don't really care about the graph right now, but I had to still graph it. Go to my table. My table says, oh, it's all ugly. How do I get my table corrected? I want to go back to 0. But it won't let me go to 0 if I just do that. So where do I do table set?
Window.
Yeah, in the window one, right above it in blue. Second window, table start at 0, counting by ones. Now go back and look at it. So it tells me right now, the highest this ball goes is, looks like 39 feet right there, so approximately 40 feet, and then it starts coming down. So what should we count by if it's going up to 40? 2s? 5s, I like 5s. So we go 5, 10, 15, 20, 25, 30, 35, 40. Okay? Now, looking at my numbers, it's going up to that and coming all the way back down in only how many seconds? 5 seconds, so I can count by ones down here. 1, 2, 3, 4, and 5 seconds. Okay? When I first started, no time gone by. How high was the ball?
6.5.
6.5 feet. How could that be?
He's that tall.
He's that tall. He's holding it up there. Boom. So I put it right there. We know, based on the work we've been doing, we got to know that maximum. Okay? Because it's going to ask us, what was the maximum height of the ball and when did it happen? And also it's going to ask us, when did it hit the ground and at what time, yada, yada, yada. So we know we need our max and we know we need that 0. So I go back to my graph. Clearly, I can't see my vertex. So we're going to zoom out. Hit zoom out, number 3. We just kind of move our little spider guy out there to where it's actually in the screen or in the data set we want. Hit enter. And even though it zooms way out, I can see my vertex now. So I go second, trace, maximum, number 4. Put it clearly to the left, hit enter. Right bound, put it clearly to the right, hit enter, and it tells me at about, rounding to the nearest 1 decimal place, 2.4 seconds, it is approximately 40.1 feet in the air. So, I go over 2.4-ish and up 40-ish. So this is 2. I would write it down so you don't have to re-look it back up. So I'd put 2.41, no, 2.4, my bad, 2.4. It was approximately 40.1 feet in the air. So we know it's going up, and we know it's coming down. So we now want to know, where does it hit? That's called a 0. Second trace, number 2 for zeros. And I have my left bound, which is above the x-axis, enter. Right bound is below the x-axis. Right there, enter, and it tells me it hits at 5. So at 5, it's back at 0. So now we can answer some questions. It says, when is a football at a height of 5 feet? Well, we can look at our graph and go, well, it's only going to be at 5 feet how many times? Once, because remember I started 6.5 feet high. So it was never over here on this side, it was never at 5 feet. Okay, so one time, so second table, I'm looking, somewhere between here, it was at 24 feet and then it dropped to 0 feet. So between what and what seconds?
4 and 5.
4 and 5. I'll take that as an answer. Between 4 and 5 seconds.
Couldn't we find the exact time?
You could. You could narrow it down if you wanted to. But if you want to just get it done and get this, boom, I'll take both. Don't worry about the window there. it asks me for an exact on this one. It says, we want to know how high the football is at 1.5 seconds. We can do that. That's our table set. Remember how we got there? You just told me. Second window, and you tell your table, hey, go ahead and start at 1.5. It'll jump right to it. Second graph, it jumps to 1.5. How high is that ball at 1.5 seconds? 35.42. So 35.42 feet. Now it says, when is the football at its maximum height? When was it? What time? We wrote it down. That's why we wrote it, so we don't have to look it back up.
2.4.
2.4 seconds. And then it asked me, what was the maximum height? We wrote it down.
I can't. 40.1.
40.1. Then it says, when does that football hit the ground? We wrote it down.
5 seconds.
5 seconds. All right, what's the domain? How far? That's my x's. How far left did this ball go?
5.
From 0 to how much to the right? To 5. Okay, range. What was the lowest this ball went?
6.0.
0 when did that happen?
Hit the ground.
When it hit the ground. How high did the ball go?
40.1.
40.1. Done. If you know all that, you will get a 100 on the test, and it will be on Google Classroom as well.